Hey guys, so today we're looking at section 7.3, which is our second to last section here in chapter 7. This is measuring and responding to change. So in these last two sections, we're going to look at specifically what is it that we're doing that's positive in terms of impacting our environment, and how is that leading to maybe some significant changes in a good way. So we've talked a lot about, the negative impacts of humans, and now we're looking more towards the future. What can we do, and how can we make our biosphere kind of how can we improve our biosphere and the living things and biodiversity that we see throughout the globe, okay, to kind of counteract all those negative activities. So again, as always, make sure you get the title here. All right. So objectives that go along with this, we're looking at, again, we'll talk about climate change here at the beginning in terms of human impacts, and then how we, in science, how scientists are using data to help us drive kind of our changes in human activities. All right. So when we look at the data here for climate change, we know that both the atmosphere, in terms of global temperatures, and oceans are both warming. We've talked about that as part of 7.2. We know that the ocean is becoming more acidic. We talked about ocean acidification, and all of that we know is linked to specifically increased amounts of two of our three greenhouse gases that we discussed, and that would be carbon dioxide and methane coming from cows and other types of livestock, and then CO2, of course, coming from fossil fuel emissions. Okay. We also know that because of all these increases in temperature, that sea levels are also rising as the ice sheets that are covering the polar regions are starting to also recede and melt and turn into liquid water. Snow cover, glaciers throughout the world, and all sorts of different types of mountain ranges are also all decreasing. And so we know as a result of this, we're impacting not only the quantity of liquid water in our oceans, but we're also then impacting our water cycle. So what we're doing in terms of the amount of liquid water that we're adding to these bodies of water, you think about what we've learned about the water cycle and evaporation and transpiration, where both of those processes are bringing water back up in the atmosphere. We're kind of throwing that whole system out of whack a little bit, okay, when we increase the volume of liquid water in bodies of water, okay? So we're looking at here, this is our data. We've seen this diagram before. These are all the different kind of human activities and the impacts that we're seeing kind of globally, okay? So for this, yes, I would make sure you get all three of these. I'm sorry, I should have said that earlier, but go ahead and jot down all of those bullets. This is a fairly short section. Okay, whoops, let me go back here. All right, so when we look at climate data here, let me see if I can move myself up here a little bit and go back. When we look at climate data, you can see I have three different diagrams here that show us the ways that we're kind of recording what's been happening kind of globally in terms of fossil fuel emissions, CO2 concentrations, methane, all of those things that we've been talking about. So the one up here at the top, you can see this is kind of demonstrating for us Arctic ice extent. And this is the area in the North Pole specifically where we're looking at the quantity of sea ice that's present at specific times in several different years. So you can see here in the date, we're looking at 1 year annually here on the x-axis from January 1 to December 31. And then each line is representing a different decade. All right, so you can kind of see the trend here. 1979 up here, peaks up in the winter months. And then as we get into spring and summer, right, the sea ice decreases just like we would expect around here, right? Our warmer temperatures are in these months down here. So June through, September, October, and then it starts to get cooler again. Same applies at the North Pole. So we see that decline and then it kind of raises up again. But what you should notice is that the trend that we're seeing here is definitely decreasing over the course of really kind of these 4 decades here. So we had significant amounts here, and now we're kind of decreasing, 2016 being this orange line, in 2006 even kind of being almost right on top of each other until we get down to here, where in these warmest summer months up in the North Pole, we have the lowest amount of sea ice that we've seen in our measurable and recorded history. So we're ending up with a whole lot less there, which kind of implies that where's that ice going, right? The only option is that it's becoming liquefied and is joining the rest of the volume of liquid water in places like the ocean. Okay. So in order to kind of assess whether or not that's happening, we can also measure the sea level change. And this is globally averaged. Okay. So this is something that we're measuring sea level at many different locations throughout the world. And then we take averages of those and we compare them kind of annually. So we're going here on our x-axis, you can see from 1900 to 2000 and beyond. And then you've got your global average sea level relative to a couple of other years in there. So when we look at this, we can see if we're normalizing and saying 1986 to 2005 is going to be, our average that we're comparing it to, well, that's where we see it reach about zero right here, right? But if we stretch all the way back to 1900, we can see that our sea level was significantly less. This is in meters. So we're ending up with kind of as a global average, almost 0.2 less in terms of meters. Okay. Now, obviously that doesn't seem like a ton, but when we look at the change within just this window of time of less than 100 years, it seems fairly significant. What's also noticeable is that here, if we go from 1986 to the early 2000s, you can see that we're already increasing pretty steadily. All right, so this seems to be a pretty constant rate of change. If not, it's actually maybe getting faster and faster as we get beyond 2005. So clearly we're seeing a change in sea levels, all right, which again could be attributed to what we're seeing here, the melting of those polar regions. In addition to that, if we take all of this and try and say, okay, well, where are we getting this data from? Well, we've got global CO2 emissions, and this is measured in gigatons of carbon dioxide, which is like much more than a ton, right? We're talking about massive quantities. And we can relate these to, again, burning of fossil fuels, or perhaps even forestry and other land use, meaning if we cut down a lot of forests, obviously we're going to get less CO2 absorption by those plants. But what's not changing here much is the forestry kind of component. So we know human population is growing. We know deforestation is part of this. However, the more significant component is going to be the fossil fuel combustion right here. So you can see, especially from about 1940, 1950 on, there's this huge increase in our use of fossil fuels, which also falls right in line with CO2 emissions kind of growing at an exponential rate. Okay. As far as these graphs go, obviously you don't need to jot these down. You're always welcome to print these things out, but I'm not going to ask you to know these specifically. All right. Just wanted to kind of review the data that we've been gathering. So when we look at climate change and in our impacts in terms of the data that's been gathered, in addition to what we just looked at, we're seeing precipitation and distribution of precipitation annually and globally has kind of been off kilter. And again, that ties in with this increased kind of volume of liquid water that's then cycling through our water cycle. We also have heat waves that we know are longer and more intense. I was going to say they're affecting populations to a larger extent. But that's again because we're losing this massive cooling part up here in our North Pole where all these glaciers are melting. You can see here the part of the Earth where we are warming most significantly is in the northern hemisphere as compared to the southern, where we still have this huge sheet of ice down here called Antarctica, which is helping to kind of keep this area cooler and more resistant to those temperature changes. In addition to all of this, we know that we have more extreme episodes of heat waves, more volatile and destructive storms. You all have heard and seen on the news, I'm sure, information about the wildfires out here in California and all the hurricanes that we've been seeing this year so far. These are certainly an indication of something happening globally in terms of our climate. Okay. So on this slide, I would maybe jot down a couple of these. In terms of, what are some things that we need to know about this? What are some takeaways? All right. So maybe pick two, or if you want to write them all, that would be fine too. All right, so when we talk about the impact of ecology, the impact of science on all of this, research we know can have positive impacts on our understanding of our climate and our biosphere, because it helps in a number of different ways. So the first thing that we know scientific research can do is it can help to recognize that there's a problem in the environment. So again, recording data and measuring things over time through observation allows us to kind of say, wait, hold on a second. When something seems off, it's likely that there's a reason for that. All right. So research kind of indicates when we might actually have a problem. In addition to that, when we gather data, that helps us to analyze a problem once it's been identified and potentially try and figure out its cause. Now, this can be something that is simply a correlation, or it can be something that's identified as a causation. And those are two very different things when we talk about scientific research. However, even identifying that there's a relationship between two different factors is going to be an important thing. And so with scientific research, we have the ability to do both of those. We also can change our behavior based on how we understand what's happening globally and what's happening based on the data that we're gathering. And so we can enact things like a Clean Water Act. We can enact things like the Clean Air Act. We can have these global climate summits that we've seen in years past in places like Europe, involving all those large countries, right? Signing these contracts, essentially these pacts that we're going to try and do our best to deal with the root issues here of climate change. So the ability of humans to change their behavior based on scientific understanding is a really important component of understanding how research kind of guides the way that we act in our environments. Okay, so this would certainly be a slide where you would want to get most of these items jotted down. I would probably go ahead and do all three if you haven't already gotten those. All right, so the last little piece we've got here for section 7.3 is about specific types of successes that we've seen in environmental studies. All right, so we know lead in drinking water. This is something that was a pervasive issue for a while, and especially was identified in the late 60s, early 70s. And we can see that we put a ban on the use of several different things, and we cleaned kind of our drinking water. We helped to purify a little bit. And so in drinking or in producing this purified drinking water, right, we're also then removing the lead from that liquid that we're responsible for consuming here, right? We also changed how we are disposing of waste and clean some of our energy sources that we're using. And so for that reason, you can see we have emissions. The amount of lead that's even being emitted by all these different processes, all these different types of energy provisions is significantly decreasing. And as a result of that, developing this understanding of how harmful lead is in drinking water and enacting some of these changes has led to a significant decrease in the amount of lead even in our environment that's been put there by any of these different types of factors. So now it's virtually not even an issue. It's like a non-issue. Although we know there are some places like in Flint, Michigan, where you probably remember hearing a year or two ago about the contamination of the drinking water there. And that was something that was maybe unexpected, because that's not something we see throughout the country at this point anymore. All right, the second type of success, the one that we've talked about before in terms of ozone and the atmosphere, was the banning of CFCs, or chlorofluorocarbons. And these were important because, remember, it allows us to kind of remedy what was happening up in the atmosphere with our ozone layer. Remember, ozone layer is really important for protecting us from things like UV rays from the sun. And so by banning CFCs, we essentially kind of reverse that process. And it's still kind of going through this regeneration process. However, it's something that will likely be kind of fully fixed and back to its original state within the next 50 years or so. Use of corridors to correct habitat fragmentation issues. This is that idea where if we have pockets of a habitat, little fragments of a habitat that have been isolated based on development and creation of things like neighborhoods and communities, there are lots of scenarios and cases where we've employed the use of what are called biological corridors, which allow species that need to be able to move to kind of continue moving from one piece to the other. So it helps to allow them to continue along their normal behavior, which is really important for species survival. The last one here, organisms being taken off of endangered or threatened lists, that would be many, many examples. When you talk about manatees in the Gulf of Mexico and changes in fishing and boating routes, which have occurred there, which has helped to increase the number of those species or that population specifically. Bald eagle populations and understanding the impacts of DDT on that population and on the ability of eagles and large birds of prey to actually be able to reproduce has helped us to increase their population sizes also. So again, all of this ties in with, all right, the data is there, the research is telling us this. Now, what do we do to change that? So the important component of all of this would be that we're using science in an appropriate way to help drive our changes in policy, our changes in the government, and our changes in society and our behavior. Okay, so I believe, yep, that was it for 7.3. So at this point, I'm going to be done. I have a little assignment for you, but beyond that, I don't have any other videos for this. So I'll catch you back here for 7.4 in a little bit. Bye, y'all.